the unit weight determination. So please comment if I am audible or not. Okay. Chalo, let's start. Let's begin our discussion. Okay. Let us begin our discussion. काफी कुछ बताना है आज. Let us start our discussion. Okay. Are you all there? So, unit weight, we have already seen what were the various methods for water content determination. Today I will show you how to determine the unit weight of soil. So, let us see. See, here we will see the determination of the bulk unit weight of soil. So, let us see how to determine the bulk unit weight of the soil. Okay, my dear friends. Let us see this. Okay, we have already seen what are the various types of unit weights. Today I will show you how to determine the bulk unit weight of soil. See, in the case of bulk unit weight we know what is bulk unit weight of soil, that is total weight of soil divided by total volume of soil. Weight of soil you can easily measure from the weighing scale. The problem is with the volume of soil. So, whatever methods I will teach you today, they will focus on determination of volume of soil only. So, let us see one by one what are the various methods involved in determining the volume of a soil. One more unit weight that is very significant for soil is the gamma D. See, whatever methods I will teach you today, with that you can only determine the bulk unit weight, not the dry unit weight. Dry unit weight you can't determine from any experiment. That you can calculate using the gamma T. We already know the relationship between gamma D and gamma T. Gamma D is equal to gamma T upon 1 plus W, where W is the water content. Water content determination we have already seen. Once we know the gamma T, we can easily calculate gamma D. And what is the practical significance of gamma D, you remember? With the help of gamma D, you can easily calculate what? You can easily see the degree of compactness of the soil. So, degree of compactness of the soil is generally studied with the help of gamma D. So, let us see how to determine the gamma D of the soil, gamma T of the soil, that is the bulk unit weight. We have many methods. The various methods involved are core cutter method, water displacement method, sand replacement method, water balloon method, and lastly the radiation method. One by one I will go through all the methods in detail. Let us first start with the core cutter method. Okay. What is this core cutter method? In the core cutter method, we use a core cutter like this. This is the core cutter, this is my dolly, and this is the cap. So, what we have to do is, you have to insert this core cutter whose inner dimension you already know. You do not have to remember the inner dimension, nobody will ask you. So, we already know the inner dimension of this core. So, just you will insert the core inside the soil and you will excavate and obtain this core with the soil, and this core will be filled with the soil. Then you will level both the surface and measure the weight of the core cutter with soil. So, first we will have the weight of the empty core cutter. W1 is the empty core and W2 is the weight of core plus soil. Volume of the core will already be known. So, you will insert this core inside the soil. You will excavate and obtain this core with the soil, and you will measure its weight, that is weight of core plus soil. From there you will get the weight of soil. So, weight of soil will be simply W2 minus W1 and gamma T will be equal to what? W by V. So, just we will insert the core like this in the soil. Okay. This is the exposed surface. Here I will insert the core. Here you will insert the core. This core will be inserted like this, and once it is inserted, you will excavate the soil and bring out the core outside, and bring out this core outside. Okay, bring out this core outside, and once you will get this core outside, level the surface of the core and find out the weight of core plus soil, and from there you can easily calculate the 𝐂𝐴𝐴 because inner volume of the core is already known. See, this method is suitable only for soft clays, soft fine grained soil. For gravels and sands, you can't use the core cutter method because the moment you will lift the core, what will happen? The sand and gravel that is stored inside this core cutter will just fall. And you can't insert this core cutter inside the stiff clays as well. So, if you try to insert this core cutter inside the stiff clay, what will happen? The core might get deformed. So, this method is suitable only for soft fine grained soil when the surface of the soil is exposed. So, obviously it is a field test, it is done in the field. It can be used only for soft fine grained soil, not for dry gravelly as well as stony soil, that is soil full of boulders and cobbles. In those soils also you won't be able to use it. It can be used when the surface of soil is exposed and core cutter can be driven. So, it can be used only when the surface of the soil is exposed, then only you can insert the core cutter, otherwise you won't be able to do it. And if somebody says me that find out the unit weight of soil located at great depth, there I won't be able to use the core cutter because here the soil surface is not exposed. Okay. So, this was my core cutter method. Please see. Shall I proceed towards the next method? That is the water displacement method. That is a lab method. Very interesting method. Let's talk about the water displacement method in detail. Let us talk about water displacement method. Any doubts till here? Please tell me. Is it okay till here? Is it okay till here, my dear friend? Tell me fast, please. Please tell me if you have any doubts till here. Okay till here? Very good. Now, let us see the next method, that is the water displacement method in detail. In the water displacement method, what you will do? You will have a chunk of soil brought from the field. So, we will have this chunk of soil brought from the field. From this chunk of soil, you will extract a soil sample. This is the chunk of soil brought from the field. This is a lab method. From this chunk, you will take out a soil sample. You will take out a soil sample. You will weigh this soil sample. Let me say that the weight of this soil sample is W1. Weight of this soil sample is W1. Now, you will coat this soil sample with a special wax. That wax is known as paraffin wax. Just melt the wax and pour it on this sample and let this wax dry. So, the wax will cover this soil sample. And now weigh the wax plus the sample once again. So, weight of the sample coated with the paraffin wax. Let me call this as W2. Now, what you will do, take this paraffin wax coated sample, put it inside a beaker filled with water and measure the volume of water displaced by this coated sample. So, let me call that V2 is the volume of water displaced. Volume of water displaced will be nothing but volume of this coated soil sample. Now, you understood why I have coated this soil sample with paraffin wax? So that water does not enter inside the soil sample. If water enters inside the soil sample, the unit weight of the soil will change. So, to cut off the contact between this water and the soil sample, we have made use of this paraffin wax. Now, we will calculate the volume of the water displaced. This is nothing but the volume of this coated soil sample. This is my volume of the coated soil sample, volume of the coated soil sample. Now, using this we can calculate the gamma T. How? See, gamma T will be equal to what? Very simple. First, find out the weight of wax, W wax, that is W2 minus W1. Volume of wax we will know because specific gravity of wax is already known. So, G wax into gamma W, where G wax is what? Specific gravity of wax. Gravity of wax. Now, V2 is the volume of water displaced. V2 is what? Volume of water displaced. And V2 will be equal to volume of soil plus volume of wax. V1 is volume of soil. See, volume of wax is already know, V2 we know, so V1 will be equal to V2 minus V wax. And once we know V1, we can easily calculate WV by V1. So, like this you can calculate the unit weight using the water displacement method, and this is a lab method. Okay. So, it is a lab method, it is used when a chunk of soil is brought from the field. Very simple method. Please see if you have any doubt, let me know. See, paraffin wax we are using, so specific gravity of wax we will already know. From wherever you will procure the wax, you will know the specific gravity of wax, and it is around 0.908 only. It's correct, Mr. Akash. It will be given to you in the exam, don't worry. So, this was water displacement method. Now, let's talk about the next method, that is the sand replacement method. Now, we will talk about sand replacement method. It is okay till here, please see. If you have any doubts, please ask me. Any doubts till here, my dear friends? Tell me fast. Then I will show you a next interesting method, that is a sand replacement method. Is it okay till here? Can I proceed further? Tell me fast. I am waiting for replies. Can we proceed further, my dear friends? Can we proceed further? No doubts. Very good. So, this is a sand bottle that we will use. in the sand replacement method, first you will excavate and you will find out the weight of the excavated soil. So, what you will do here? Very simple method. First you will excavate the soil, but volume we do not require. So, W is the weight of excavated soil. Very interesting method. Now, I need to find out the volume of this pit. To find out the volume of the pit, we will use this sand bottle. So, what you will do here, you will take this sand bottle, keep it on this pit, okay, keep it on this pit. This sand bottle had a cone on the bottom. This is my sand bottle, it is initially filled till here. This is the initial level of the cone on the sand bottle, and this is the cone. So, just remove this valve here, just remove the valve and the sand will start pouring. The sand will start pouring here, and this sand will get filled. Now, the sand will start pouring here, okay. The sand starts pouring inside the cone as well as the pit. We will find out the weight of sand in cone plus pit here, by recording the initial and the final weight of the sand bottle. So, you will find out this, that let me call this as W1, weight of sand in cone plus pit. Now, again take this sand bottle, open it on a plane surface. Open this sand bottle again on a plane surface. Take a plane surface, open this sand bottle on this plane surface. You will not fill this bottle with the sand. Whatever is filled was filled. And you will find out the weight of sand in cone only. Okay. Second step, what you will do? You will open it on a plane surface and you will find out the weight of sand in cone only. Let me call it as W2. Weight of sand in cone only. Okay. Now, W3 is weight of sand in pit. W3 will be equal to W1 minus W2, and volume of pit, V is the volume of soil in pit. This will be equal to what? W3 weight of sand in pit divided by gamma sand. That is the unit weight of sand that is inside this cylinder. We will already inside the sand bottle, we will know. Once you know the V, we can easily find out gamma T, that is W by V. This is my sand replacement method. See, very simple method. Very simple method. Obviously, it is a field method. It is everything is done in the field, and it is used for those soils in which the core cutter cannot be used. You remember, core cutter can be used only for soft fine grained soil, not for sandy, gravelly or stiff clays. So, in those cases, we can go with this sand replacement method. Okay. So, it is a field method. It is used for sandy, gravelly and dry soils in which core cutter cannot be used. Very simple method, please see it. Okay. Why we have provided the cone here? Why we have provided a cone here? See, whenever the sand is dropped, it will take the shape of a cone. Have you seen a time clock? So, whenever you will pour a sand, it will always take the shape of a cone. If you will take a plane surface, what will happen? See, if instead of this cone, you are taking a plane cylinder. So, what will happen? See, please try to understand. If instead of this, if you would have taken a plane cylinder only, So, when the sand gets poured, it will take the shape of a cone, and some volume might not be filled with the sand, okay, because whenever the sand pours, it takes the shape of a cone, and there will be error in the experiment because some volume will not be filled with sand. So, therefore, to ensure that all the volume is filled with sand, we make a cone here. Got my point? Therefore, this cone is very important inside the sand bottle. Got it? Why this cone is provided? Very interesting one. These type of questions can be asked in the interview as well. Can I proceed further? Now I will tell you about the water balloon method. Radiation method is not important. We will cover only till the water balloon method here. Any problem till here? Please tell me. Can I proceed? Is it clear to you? Okay. Okay. Let us see the last method, that is the water balloon method. See, it is similar to the sand replacement method. Just to find out the volume of the pit, we will use this water balloon. So, here I have an apparatus which is filled with water. Okay, this apparatus is already filled with water. This has a water inside. Make a pit, measure the volume, weight of the excavated soil. Now, to measure the volume of the pit, what you will do? To measure the volume of the pit, what we will do? Just insert pressure, apply pressure to the water here. This water will fill this membrane and this membrane will take the shape of the pit. Whatever volume of water is required for this membrane to take the shape of the pit will be will be recorded on this graduated scale, and this will give me the volume of pit. Weight of the excavated soil is known, volume of the pit you can find out from here, and like this you can find out the gamma T. Very simple, it is all written here. So, in this method, volume of excavated pit is obtained by covering the pit with thin rubber membrane and noting down the volume of water used for filling it. A balloon density apparatus is positioned over the hole, and instead of using sand to measure the volume, the calibrated vessel is pressurized, forcing a rubber membrane into the excavation. So, this rubber membrane will be forced into the excavation and it will take the shape of the pit. Graduation of the vessel are read to find the volume of the excavated hole. Okay, got it? This was my water balloon method. Now, let us solve some questions on these concepts. Now, let us see some questions as well. Time for some questions now, my dear friends. Let us see some questions here. Okay, let us see some questions here. Radiation method is not important. Let us see this question now. Please solve this one, this question. Please try to solve this. Okay, waiting for answers. Tell me. 15.94 you are getting. Let us try to solve this. A standard core cutter of volume 1000 centimeter cube. So, we have a standard core cutter having volume of 1000 cc, okay, and mass weight of the empty core cutter W1 is 950 grams, is used to determine the weight of a compacted clayey soil embankment. The total mass of the core cutter full of soil excavated, that is W2, 2900 grams, okay. A representative sample of 30 gram taken in an oven dry yields a dry mass of, this will be used for using the water content. Water content is simply I am writing 30 minus 25 upon 25, that is 0.2, 5 by 5, that is 0.2, okay. This is water content we got. G is 9, the dry unit weight we have to find out, okay. Weight of soil, W is the weight of soil, that is W is W2 minus W1, 2900 minus 950, 1950 grams. Now, gamma T will be simply equal to W by V, that is 1950 upon 100, 1000, that is 1.95 gram per cc. Now, gamma D is gamma T upon 1 plus W. 1.95 upon 1 plus 0.2 into 9.81 we will multiply to get your answer in kilonewton per meter cube. Density we can convert it into kilonewton per meter cube just by multiplying 9.81. So, 1.95 divided by 1.2 into 9.81. So, 15.94 you are getting very correct answer. Simple and interesting. 15.94 you have calculated, very good Mr. Akash. So, correct answer is A only. You are giving me A as the answer and A is the correct answer only, okay. Let us do one question on the water displacement method as well. Do this question, try this one out, try this one as well, do it fast. Have you done it? You are getting as 18.98. Let me see what the answer should be. 18.98 you are getting, na? Yeah, that's correct. It's correct, my dear friend, Mr. Akash. Your answer is very correct, my dear friend. Very good. Mr. Akash, you have good concepts on geotech, I must say. Very good. A soil chunk was irregular in shape, is tested in the laboratory using the water displacement method. To find its bulk in the observation, mass of the moist soil sample. So, mass of the moist soil sample W1 is how much? 60 grams. Weight of the soil with wax W2, that is 63.6 grams, and volume of the water by the wax displaced, that is V2, is 35 cc. G wax is 0.9. And G you will take as 9.81. Find out gamma T. Very simple. See, weight of wax W2 minus W1, that is 3.6 grams. Volume of wax is V2 minus, sorry, weight of wax by G wax. Gamma W I will take as 1 gram per cc because everything is in gram per cc. Okay, 3.6 upon 0.9 into 1. Gamma W I have taken as 1 gram per cc here. So, this is 4 cc. Now, volume of soil V1, V2 minus V wax, 35 minus 4, 31 cc. Gamma T is W1 by V1, that is 60 upon 31 into 9.81 you will multiply to get the answer in kilonewton per meter cube. How much you are getting? Tell me fast. 60 divided by 31 into 9.81. 18.98, my dear friend. It's a very, or 987 I can say. Nearest answer I will click here. Very good. That is, nearest answer is C here. You have given me C as the answer. Very good. Okay. Next, last question, please do it on the sand replacement method. Okay. Try to do this one as well. Very interesting. See, 1.8 you are getting gram per cc we have to report. C answer you got. C is the correct answer, my dear friend. You can't be wrong. I know this. C is the correct answer. Very good. Let's try to solve this out. Very simple question. See, mass of the sand pouring cylinder filled with sand up to the top was m1. Mass of sand pouring cylinder after running the sand in the into the calibrating container, that is 4.8 kg. So, mass of sand in calibrating can, I will write, let me call it as W1. Mass of sand in this calibrating can will be used to find out the gamma of sand. Okay, W1 is how much? M1 minus M2. 7.5 minus 4.8, that is how much? 3.7 or what? 7.5 minus 4 point, that is 2.7, sorry, 2.7 kg. Okay. Now, mass of sand in the cone, it is given to me as 4.45. Internal volume of calibrating container is Vc. So, gamma sand W1 by Vc, that is 2.7 into 10 raised to power 3 kg upon 1500 gram per cc you will get. 1.8 gram per cc. Mass of wet soil excavated from the test hole is 3.24. Mass of sand cylinder after filling the excavated test hole, that is 4.35 kg. So, mass of sand in the cone and mass of sand pouring cylinder after filling the excavated hole is 4.35 kg. Now, we have to just find out the row of excavated soil. For that we, this is the last session for Geotech. We will cover Geotech up to here only. From tomorrow you will see the next subject. Okay. Okay. Mr. Akash, am I clear till here? Now, mass of sand pouring cylinder after filling the excavated hole. So, it was 4.8 till here. After that, mass of sand. So, this is W2, mass of sand in hole plus cone. This will be equal to how much? M2 minus M3. Okay. This will be M2 minus M3, na? 4.8 minus 4.35. 0.45 kg. Now, W3, mass of sand in hole only, that will be equal to W2 minus MC, mass of sand in cone only. 0.45 minus 0.43. Okay. 4.35. This will come out to be 0 then. Something wrong have happened here. Mass of sand in cone we have taken. This should be this should be M1 minus M3. Na? When we have started the experiment, we have filled the sand once again. This should be M1 minus M3. Otherwise, you will not get the correct answer. Na? This should be 7.5 minus this one. This should be 3.15 kg. Now, this sounds perfect. 3.15 minus 0.45. Now this sounds perfect. Otherwise, calculations were getting hampered. 2.7 kg. Volume of hole W3 upon gamma sand. 2.7 kg into 10 to the power 3 upon 1.8 cc you will get, है ना? That is gamma sand was not coming out properly, na? Okay, mass of sand in calibrating can. Here you will subtract the mass of cone also. Here you should subtract the mass of cone also. One mistake I have done here, 7.5 minus 4.8. The mass of cone, sand in cone should also be subtracted, minus 0.45 equal to how much? 7.5 minus 4.8 minus 0.45. So, it's coming out to be 2.25 kg. This will be 2.25, huh? This should be corrected here, my dear friend. This is 1.5 gram per cc now. This should be 1.5 here. Now you will get the correct answers. This will coming out to be 1800 cc. Gamma T will be equal to what? W by V. Weight of soil, wet soil excavated is 3.24. That is MW by V. 3.24 upon 1800 into 10 to the power 3. Answer will be in gram per cc. Correct. So 3.24 divided by 1800, 1.8 gram per cc is the correct. Now it's perfect. Now it's perfect. Okay. Very good question, but very good question. 1.8 gram per cc is the correct answer. Very good. So like this you can solve it. This is my Telegram channel link for your reference. You can join in me here if you have any queries. All the best for the future sessions. Study hard, then only you will get good ranks in GATE. All the very best. Bye bye. Take care.